Okay, here are just some notes to help you with the particle motion homework. The slope between 2 points, we've known that information for a long time. And that is the change in y, or the change in x. Or we can call it the change in the dependent variable over the change in the independent variable. So when we write the derivative of f as units, and the units are the units of f of x, or the y value, over the units of x. So when we write our units, it's important to know. Now from the videos, we learned that if the first derivative is greater than 0, then f of x is increasing. And we also learned that if the first derivative is less than 0, then the function is decreasing. That's stuff you have to know. Now in the video, we learned a really good way to justify with what we call a sentence frame. And I really like this sentence frame because it includes all of the information, 4 pieces of information that you need for the AP exam to get full points. I think it's really important that this be something that you have maybe written down or you keep handy. So let's do one. We have the number of gallons of water in a storage tank at time t in minutes modeled by W of t. And they want you to interpret W prime of t equals -8. So using our sentence frame, they would say at 10 minutes, because that's what t is, the water decreases. And the reason it decreases is because 8 is negative at a rate of 8 gallons per minute. Now here's Mr. Sullivan, and he wants Mr. Bruce to do something. The number of packets completed is modeled by P of W, where W is measured in weeks. So let's interpret P of 10. Now P of 10 is just a function value. So this is 10 weeks. Notice how I'm putting time at the beginning of the sentence. After 10 weeks, Mr. B has completed 1 packet. This has nothing to do with the rate because it's just a function. But now in part B, you have P prime of 39 equals 4. So now our time is 39 weeks. The rate. Now we're talking about a rate because we're talking about the first derivative. Wonder if he's working fast. Is 4 packets per week. And from a teacher's standpoint, he's working pretty good. That's a lot of packets. Now here's another one. We have a percentage grade modeled by G of T, where T is the number of hours that the student's been studying for the test. Interpret G prime of 1 equals 3. So this will be a rate, and the time is 1 hour. So in this case, student has studied for 1 hour. Now, because it's 3 and it's positive, that means that we can say the student improves. %3 per hour. So because the student studied, their rate is positive. Now, when we talk about particle motion, really kind of important that you understand the generally used function notation. When we're talking about the position of a particle, that's usually s of t. Velocity is usually v of t, and acceleration is normally a of t. So those are just commonly used function notations. Now, as far as the rules that you need to know, got to know these rules. Let's talk about velocity. When the velocity is less than 0, the particle is moving left or down. When the velocity is greater than 0, the particle is moving right or up. And when the velocity is equal to 0, that means the particle is at rest, it's not moving up. Average velocity is used often, and we do that the same way we did the average rate of change. It's the change in the position function. And speed can be calculated by taking the absolute value of the velocity. These are all things we have to know. Now, as far as speeding up or slowing down, that's a classic sort of physics application. It's also an AP favorite. So we need to understand how to determine. And it's really quite simple. If the velocity and the acceleration have the same sign, they're both positive or they're both negative, that means they're speeding up. But if they have different signs, one's positive, one's negative, that means they're slowing down. This particular slide, very, very important. So let's take a look at an example where we have velocity and we have acceleration. And we have it for 4 values of t. And we want to know, is it slowing down? Is the particle slowing down or is it speeding up? Well, what I do is I look at the signs. I say, okay, 3 is positive, 4 is negative, 4 is negative. So because they have different signs, they're slowing down. The 2 is negative, 7 is positive, slowing down. These are both positive, so they're the same sign, so it's speeding up. And these are both negative, same sign, so that is also speeding up. And that's important to understand that. Now, as far as a problem goes, let's work a few. Here we have a really nice polynomial. Number 1 says find the displacement. So the displacement is really how far or how much change in position did this particular particle have from 0 to that 2 minutes. So what we're going to do is we're going to do x is 0, because this is a position. And x is 0 is 0 cubed minus 1. Okay, so it's 3. And then we're going to do x is 2. So we'll do 2 cubed, plug it in, and what you get is -5. So the displacement would be this amount. Which means the displacement would be -8 centimeters. Number 2 says find the average velocity. So what I would do, because this is position, I would say, grab my average rate of change formula. I know what x2 is. I know what x0 is. And that is -4. And we will put units on it, centimeters per minute. You do lose points if you don't use units. Now the velocity is easy. That's just the first derivative. So v prime is 3t squared minus 8t. And we'll plug in 4. And we should get, let's see, I calculated that already to save us some time. 16 centimeters per minute at time equals 4 minutes. Now acceleration, that's going to be the second derivative. Probably should have mentioned that back a couple slides ago, sorry. Okay. So we'll do 6t minus 8, and we'll do a4 which is also coincidentally, doesn't normally happen that way. 16. So is it speeding up or is it slowing down? Well, look at the signs. The acceleration is positive, the velocity is positive. So since the signs are the same, it's speeding up.